I've had a question about Unit 1, Homework 6, a problem similar to number 6, which is the absolute value of the quantity 2x plus 7 is less than or equal to 19. And I made some notes for you on our second screen, so let's pop over there. So note that we're talking about capital X here, and X is either a variable, so it's a variable, or a variable expression, and that if the absolute value of X is equal to A, then X is A or negative A. It's equal to A or equal to negative A. If the absolute value of X is less than A, we remove the absolute value bars and rewrite that as X between negative A and positive A. Or we could also read this as negative A is less than X, which is less than positive A. And then the third possibility is where the absolute value of a variable or a variable expression is greater than A, and in that case we're looking at the two tails of a graph. So that means that the X, the variable or the variable expression, is either less than negative A or it is greater than positive A. So there's our three possibilities, and in this section we're dealing with inequalities. So let's take a look at the example, the problem that was sent to me. So since this is the absolute value of a variable expression, 2x plus 7, less than or equal to 19, then this is going to be X is between 19 and negative 19, X being our variable expression. So we will rewrite our inequality without our absolute value bars. So we have 2x plus 7 less than or equal to 19, or it is greater than or equal to negative 19. And the notes that I put on that second screen, you need to be able to recognize which part you're looking at, so you'll know how to rewrite the inequality without the absolute value bars. Now we'll solve this. Let me change colors here. So we will subtract 7, subtract 7, subtract 7. So now we have negative 26 is less than or equal to 2x, which is less than or equal to 12. Divide by 2, divide by 2, divide by 2. So we have negative 13 less than or equal to x, which is less than or equal to 6. Now, we need to write this in interval notation. The absolute best way to write a solution in interval notation is to do a graph. So this is one of those things where it will take a little more time, but you'll be much more likely to get a correct answer. So in math, sometimes we just have to go really slow at first so that we can go faster later. So I'm going to draw a number line, and I don't need a lot of numbers here. I'm going to put a 0 and a positive 6 and a negative 13. I want to change colors again. So now we know that our x is greater than or equal to negative 13. So that means it has to be a square bracket. Because it is less than or equal to, we have to use a square bracket. And that is x is greater than all of those. So it's everything to the right of that square bracket. It is also less than or equal to 6. So another square bracket, but this time it's all the x's that are less than or equal to 6. Now we could check our solution real quick here. For example, if you put 0 in there, which is in the interval, that is a right number. That will work. But what if you use 7? If x equals 7, is it between negative 13 and 6? It's not. So that gives you confidence that you've got the right interval marked on your number line. Now let's translate this to interval notation. Remember that interval notation is a way of writing the solution set using symbols without the graph. So it's the symbols that explain this number line graph. So we always start on the most negative side. From negative infinity, we don't have anything until we get to negative 13. And since we had a less than or equal to, that is a square bracket and then a comma. And now we go in the positive direction all the way to 6, and that's where we stop. And again, we need a square bracket because that is also a less than or equal to. So the graph is square bracket, all the x's in between, and the interval notation is square bracket negative 13 comma 6 close square bracket. So let me know if you have any other questions on this.